The question here is, what are some methods available for stress transformation? Here's the stress transformation problem. Given the components of the stress with respect to the XY Cartesian coordinate system, we need to find the components of the stress with respect to a rotated system where x prime axis is rotated counterclockwise from the x-axis through an angle theta. More precisely, given sigma x, sigma y, tau xy and theta, we want to find sigma x prime, sigma y prime and tau xy prime. We will refer to the first class as the mathematical methods, and there are two of them. The first one, we derive one equation for sigma x prime, another one for sigma y prime, and a third one for tau xy prime on the basis of equilibrium or Newton's law. So once we have numbers for these quantities, all we have to do is to substitute in these equations, and then we can calculate values for sigma x prime, sigma y prime, and tau xy prime. The second mathematical method allows you to find the principal stresses and their directions. You might recall stress is actually a tensor, right? So in this method, you treat the stress as a tensor. You might also recall that we usually use the mathematical symbol of matrices to represent a stress tensor like this. And in this method, you find the determinant of the 3 by 3 matrix, and you'll get 3 values for lambdas out of this. And you can show that these 3 values are the principal stresses of this stress tensor. You can apply this method for 2D stator stresses as well. You'll get 2 values, 2 principal stresses. And then for each of the principal values, lambda 1, lambda 2, and lambda 3, you solve for 3 vectors, n1 and n2 and n3 from these 3 equations, and these vectors are the principal directions. The second major class of method is a graphical method known as the Mohr circle analysis. We know as we change this angle theta, the magnitude and the signs of these stresses, sigma x prime and tau xy prime, keep changing, right? It turns out that as you keep changing theta, the combination sigma x prime and tau x prime lie on a circle. So this circle is what is called the Mohr circle. Each point on the circle represents a plane of a specific orientation, like this plane right here. So if I were to call this plane as x prime plane, because this plane is perpendicular to the x prime axis, the magnitudes of sigma x prime and tau x prime y prime would place that point on the circle like this. And similarly, there is the x plane and then there is the y plane, right? So x plane would plot something like this and the y plane would plot something like this. Points A and B represent the principal plane, the planes where the shear stresses are 0, but the normal stresses are either maximum or minimum. Point C and D represents the plane containing the maximum shear stress. The shear stress is the vertical coordinate, right? So you can see as you go around the circle, these are the 2 points where the shear stress assumes its maximum value. Anyway, this gives you some broad idea, and using these principles you can solve the stress transformation problem. We will not pursue the eigenvalue method in the videos to follow, but we will follow the mathematical method based on equations and the graphical method known as the Mohr circle analysis.